Okay, I hope you're watching closely. I'm going to take you through this work that you need to do on lesson 5.5, so pay close attention. So you're going to be learning, yesterday we did, 45, 45, 90-degree triangles. This time we're doing a different right triangle, which are the 30, 60, 90 right triangles. And again, we're going to look at stamps, triangular stamps. This one was, the first one here comes from Malaysia. And this one here, you can see, it's actually an equilateral triangle. And what that means is, each of the sides are equal, right? So, it's asking you how the stamp's different. You're going to compare it to the previous lessons. Remember, the sides were not equal in that you had 45, 45, 90. You had a long hypotenuse here. There's no right angle in here. It says it's shaped like an equilateral triangle. So what is the measure of each interior angle of the triangle? So remember, the hinge theorem says opposite side, has to match, whichever one is the shortest, then the opposite side is going to be the shortest, and whichever one is the longest opposite side, then the interior angle opposite is going to be, the greatest. But what if all the sides are equal? Then it turns out all of the angles have to be equal. So the 180 degrees has to be split equally among the three angles. So you should be able to figure out that these are all 60-degree angles. And you should be able to put that in your own words and explain it here, because it does say explain your reasoning. Now it says use the diagram of the stamp to draw an altitude to the base of the equilateral triangle. So we're just drawing it, not constructing it. So you can go ahead and get your protractor. You can just actually, you really just need a straight edge. You're just going straight from the top here, and altitude straight down. So use a straight edge and just draw it straight down from the top to the bottom. Try to make it drawn as a straight line. And what you're going to end up with is two separate triangles. Now we're going to think about it. I want you to think. I'm going to actually draw this out for a second so you can kind of really pay close attention to what I'm going to show you here. If I were to draw, now I'm not doing a good job of it, but if I were to do a good job of it, we would have two triangles and each one would be equal. This would be a right angle here. So there's your 90-degree angle. This one, you remember, was 60, right? We haven't touched it, so it's 60. But up here at the top, this one has been cut in half, right? Because we drew it right down the middle. So this one up here would be a 30. So this is what we call a 30, 60, 90. There's the 90-degree triangle. 30, 60, 90-degree triangle. Now the obvious thing here is, remember this length here, whatever length this was? So this side over here that's opposite the 30 and next to the 60, this side over here, it's the shortest side of this triangle, right? Because it's opposite that 30. It's opposite the smallest angle. This side, if you think about it, it is exactly half. It is exactly half of that hypotenuse of the regular side. So if this was 50, then this side would be 25. That gives you a formula. The short side of the triangle is equal to the hypotenuse divided in half. Or another way of thinking about it is that the hypotenuse is twice as big as the short side. I would definitely write those two formulas down. Now, I'm going to come back in a minute. We're going to revisit and try to figure out what the value of this is. But you're going to use Pythagorean Theorem to figure that out. And we're going to remember that we're going to go leg squared plus leg squared equals hypotenuse squared. In this case, this leg and that leg are related. This is just like L and this is 2L, right? I mean, it's 2 times as long. So you can do a little bit of that, and we'll do it in just a minute here. All right, I'm going to scroll down. So you draw the altitude to the base. How do you know that they're to the triangles are congruent? Well, you should have, if you drew an altitude, these would both be 90 degrees, and you would have bisected this, triangle. So then you would have ended up with two, or you would have bisected that angle up at the top, so it was a 30 and 30. Therefore, the side, this side, and this side would have all been congruent. Or one theorem is called the Hypotenuse Leg Theorem. This hypotenuse and this leg right here is equal to that hypotenuse and that leg right there of a right triangle. So by Hypotenuse Leg Theorem, those are equal. That's one way you can answer that. That's that question number 4. Now it says, if the length of each side of that stamp was 50, determine the length of the 3 sides in each of the 2 30, 60, 90 triangles formed. So how would you do it, man? You're going to actually just remember the hypotenuse is 50. So I'm going to kind of sketch this out for you, right? So your hypotenuse, I'm just going to draw the one side here. Here's our 30, 60, 90. My 30 is this one, my 60 is that one, and here's my 90. So they're saying if this is 50, we know what? We know that this one has to be 25 because it was cut in half, right? So then we use Pythagorean Theorem to solve for x. So we'd say 25, I know my handwriting is atrocious, squared plus x squared equals 50. Squared. Okay, I'll let you do the algebra on this because my work is really bad, but you're going to subtract 25 squared from both sides. You figure out what that is and take the square root, and you'll be able to solve for x, and that would be the length of this altitude here. And that's what it's asking you, right? Show your work in here, or show what you put into the calculator if you do it using the calculator. Okay, how does the length of the hypotenuse relate to the length of the shortest leg? Remember, it's going to be twice as long as the leg. And then it says, how does the length of the longer leg relate to the length of the shorter leg? Well, the longer leg, you're going to see when you do that little arithmetic, it is, right here it says it, look, √3 times the length of the shorter leg. So there's some help for you right there. How does it relate? It should be √3 times longer than the shorter leg, right? Take the shorter leg times √3. So now you're going to prove that using Pythagorean Theorem. You're going to use h for the, let's see, they want you to use x for the length of the shortest leg, and I guess you're going to use what? Hypotenuse. You'll use h for the hypotenuse, and L for the long leg, maybe? I don't know. Yeah, I think that's what I'd have you do. Okay. So let me draw that out for you. Look like this. You'd have a right triangle. Let's call this H, right? And let's call this X. And then we need to know what the length of the long leg is, so we'll call that L. I don't know. And actually what we know is that X, or the H, is equal to 2X, right? That whatever that short leg is, H is 2 times as long. So we can think of this as just 2x, right? So now all of a sudden, if you do your Pythagorean Theorem, I'm going to try and do a bunch of this here for you. So we say x squared plus L squared, right? The long leg squared is equal to the hypotenuse squared, right? And we're going to cross out, like we said here, I'm going to get a color here to cross it out. We're going to cross that out. We're going to rewrite it again, and this time we're going to use x squared plus L squared, right, equals, and this is now, we're going to think of this as 2x, not h. It's 2x, and it's squared. And when we square that, we're going to get 4x squared, right? Because we square the 2, square the x, get 4x squared is equal to x squared plus L squared. If I subtract x squared from both sides, subtract x squared from both sides, what do I get? Well, I get L squared left on this side is equal to 4x squared minus 1x squared is 3x squared. And this is what we did yesterday, you might remember. I'm going to switch to a different color here. You can see what I'm doing. We take the square root to find L, right? So we're going to take the square root. So think of a square that has an area of L squared. What would the square root of it be? It would just be L, right? So now we know whatever, take the square root here, and what we're going to do is we're going to do √3 times the square root of x squared. Well, what is x squared? The square root of x squared. If you had a square the size of x squared, area of x squared, then each side would have to be x. So L is equal to √3 times x. And there's your work, okay? I've actually done it for you, so you might have to pause that, rewatch it if you want. It's all here in Classroom, and you should be fine. All right, here you have it. They're going to tell you each side is 40, so now they're going to want you to use that theorem. So this is 40. I'm going to just tell you right now, that's got to be 20, and this one's got to be 20 √3, right? I mean, but you'll need to explain that Over here you have another one. They're saying if this is 30, now this is a little bit trickier. If the height is 30, then we've got to divide that by root 3 to find out the length here. Okay? And that would give us the short length, and then we double that to find the hypotenuse. So it's a little bit of work in there, but watch closely what I said, and you should be able to do it. Here you go again. We have the height being 42. That's the height of the pyramid inside. So this is 42. Then this has to be 42 divided by root 3. All right, let me give you that formula real quick again. Okay, you need to have that just to be sure. If you say that your short side is equal to 2 times the hypotenuse, right? Or you could say the hypotenuse is equal to, oh, that's not correct. Okay, sorry, let me erase this. Let's try that again. Let me get a better color. Here we go. Whatever the hypotenuse, it is twice as long as the short side, right? 2 times the short side. And the short side is equal to the hypotenuse divided in half, right? H over 2. So then we have the question, what about the long side? Well, the long side is equal to the short side times root 3, right? Which we just did in Pythagorean Theorem. And that means I would say the short side could also be thought of as the long side divided by root 3. Okay? So, if they're telling me this is 42, then this short side, I just take 42 divided by root 3. I'll have the short side. And then when I know the short side, I can just double it and I'll have the hypotenuse. Okay? Now they want to know the area. So the area is going to be whatever this base is, right? Whatever the hypotenuse length is, right? Times the long side. And it's 1/2 times the height. So 1/2 times the long side times the base, which is the hypotenuse. So that's the area of a triangle. Don't forget that formula. Area equals, for a triangle, 1/2 times the base times the height. Don't forget, we're not talking about just the short side of this 30, 60, 90 triangle. It's the whole base. So it's the same length here as it is there. Either one of those could be considered the base. The long side is the one that you're going to be thinking of as the height. Okay? Now, you got to construct this. This is a little bit trickier. And you're going to construct it. So, if you remember what we do to construct something, we can start by making, let's see, they want us to make an equilateral triangle and get the altitude of it. Okay, you know what, why don't you skip this and we'll do this on Monday, okay? I'll help you with the construction on Monday. It's a little bit hard for me to do this. On this side here, I want you guys to finish this out, and then if you have any time left in the class, and you can do this, I think by now, if you don't understand, you got to go back and rewatch the video, that's fine, but you should be able to answer this. I'm going to let you answer that one on your own, all the way down through the end of this, okay? The formulas we've already had and given to you, so you should be able to answer all that. Make sure where it says explain, so explain how it's calculated, and here it is again for 3, explain, make sure you're explaining, because I'm not giving you credit just to write somebody else's answer, and you got to explain it in your own words. And we'll do the construction together on Monday. Okay, thanks. Have a great weekend.